Hello everyone, and welcome to another math video. I'm Professor Diawa, and in this video I'll be going over the slope of a line. The objectives are to find the slope of a line given 2 points on the line, find the slope of a line given the equation of the line, find the slopes of horizontal and vertical lines, find the slope of a line given the graph of the line, compare the slopes of parallel and perpendicular lines. Alright, so let's get started. First, we have the slope-intercept form of the equation of a line. This is written as y equals mx plus b. M represents the slope, and b represents the y value of the y-intercept. The y-intercept is written as parentheses 0, b, close parentheses. In the next example, I'll show you how to find the slope and the y-intercept of a line, and I'll show you how to take an equation and put it in slope-intercept form. Here we have example number 1. We need to find the slope and the y-intercept of each of the lines. For part A, we have y equals -1/2 x plus 1. You can see that this equation is written in slope-intercept form. The slope is the number that's in front of x, which is -1/2. Be really careful when you're writing out your value for the slope. Many times students will write this as -1/2 x. But make sure you only write out the numerical value -1/2. The y value of the y-intercept is 1. So the y-intercept is written as parentheses 0, 1, close parentheses. Moving on to part B, we have the equation 3x minus 4y equals 4. Here we need to put this equation in slope-intercept form. To do this, we first get rid of the 3x by subtracting 3x from both sides. Simplifying the left-hand side, the 3x and the minus 3x cancel out, and we bring down the minus 4y. On the right-hand side, we could bring down the 4 and the minus 3x. The result is -4y equals -3x plus 4. From here, we need to isolate the y by itself, so we get rid of the minus 4 by dividing both sides by -4. Doing the division, we have -4y divided by -4 equals -3x divided by -4 plus 4 divided by -4. Notice on the right-hand side, I divided each term by -4. This is because we want to put the equation in slope-intercept form. Next, we go ahead and simplify. On the left-hand side, -4y divided by -4 is y. On the right-hand side, -3x divided by -4, we could rewrite as +3/4 times x. And for the last term, +4 divided by -4 is -1. The result is y equals 3/4 x minus 1. Now that we have the equation in slope-intercept form, we could see that the slope is 3/4, and the y value of the y-intercept is -1. So the y-intercept is written as parentheses 0, -1, close parentheses. Next, we're going to go over the slope. Here it states the slope of a line passing through the points parentheses x1, y1, and parentheses x2, y2 is given by the equation m equals the fraction rise divided by run, which is also equal to the fraction y2 minus y1 divided by x2 minus x1. So we use this formula to find the slope whenever we're given 2 points that lie on a line. Looking over to the left, we have a graph which displays only quadrant 1. On this graph, we have 2 points, x1, y1, and x2, y2. Going through those 2 points, we have a 45-degree line, which also goes through the origin. To find the slope of this line, we need to find the rise and the run. Let's start by taking a look at our points x1, y1, and x2, y2. First, we need to find the rise. The rise is the vertical distance between these 2 points. To find the vertical distance, we just take the difference between the y values of the y coordinates. You can see over here the vertical distance is represented by y2 minus y1. To find the run, we need to find the horizontal distance between these 2 points. The horizontal distance is found by finding the difference between the x values of the x coordinates. You can see here that our horizontal distance is represented by x2 minus x1. The ratio between the vertical and horizontal distance makes up our slope. In short, this is just rise over run, or the difference between our y-coordinates over the difference between our x-coordinates. In example number 2, find the slope of the lines drawn in the graphs. For part A, the graph of the line has 2 points given. The first point is at the origin, which has the coordinates 0, 0. The second point has the coordinates of 2, 3. To find the slope of this line, we just use the slope formula m equals y2 minus y1 divided by x2 minus x1. Now you could choose either one of these points to be your x1, y1 and x2, y2. I chose 0, 0 to be my x1 and y1. I chose 2, 3 to be my x2 and y2. Substituting in these values into our slope formula, we get 2 minus 0 divided by 3 minus 0. This equals 2 over 3. So our slope for this line is 2/3. Moving on to part B, we're given a line with 2 points. The first point is 0, 2, and the second point is 4, 0. Again, we just use our slope formula. So my first point, 0, 2, will be my x1, y1, and my second point, 4, 0, will be my x2, y2. Plugging in these values into our slope formula, we get 2 minus 0 divided by 0 minus 4. This equals 2 divided by -4, which simplifies and gives us -1/2. So our slope for this line is -1/2. Next, we're going to talk about the slopes for horizontal and vertical lines. The slope of a horizontal line m is equal to 0. In the diagram below, we have a graph of a horizontal line. We labeled several points. We have -1, 3, 0, 3, and 2, 3. If we use the slope formula, we should get a slope of 0. So I'm going to use the 2 points 0, 3 and 2, 3. Plugging in the values into our slope formula, we have 3 minus 3 divided by 2 minus 0. This is equal to 0 over 2, which is equal to 0. So this gives us a slope of 0. The reason why horizontal lines always result in a slope of 0 is because the y values for any 2 points on a horizontal line will have the same value. You could see in our example, the y values y2 and y1 are the same value, so taking the difference will always result in 0 in the numerator. Moving on to vertical lines. Here it states the slope of a vertical line m is undefined. If we take a look at the diagram below, we have a vertical line with 3 points labeled. We have the point -2, 3. We also have -2, 0, and the third point -2, -4. To find the slope of this line, we just use the slope formula, and I'm going to use -2, 0 as my x1, y1, and -2, -4 as my x2 and y2. Substituting those values into my slope formula, I get -4 minus 0 divided by -2 minus parentheses -2. Simplifying this, we get -4 divided by 0, which is undefined. So our slope here is undefined. Now the reason why vertical lines always result in a slope that is undefined is because the x values for any of the points of a vertical line will always be the same. You can see in our example that our x2 and our x1 have the same values. When we take the difference between these values, this always results in a 0 in the denominator, which makes the slope undefined. Next, we're going to go over 2 definitions. First, we have the definition for parallel lines. Here it states 2 non-vertical lines are parallel if their slopes are equal and have different y-intercepts. In the illustration, you can see that we have an example of 2 parallel lines. Next, we have the definition for perpendicular lines. It states here that 2 lines are perpendicular if the product of their slopes is -1, or if one line is vertical and the other is horizontal. In the illustration on the right, you can see that we have an example of two perpendicular lines. In the next example, we're going to use this information to determine whether or not a pair of lines are parallel or perpendicular. For example number 3, determine if each pair of equations are parallel, perpendicular, or neither. For part A, we have the equation x plus 2 equals y, and we have the equation y minus x equals negative 2. The first thing we need to do here is rewrite both of these equations in slope-intercept form. That way we could compare the slopes and the y-intercepts. For the first equation, we could just flip it, and this gives us y equals x plus 2. You could see the slope for this equation is 1, and the y-intercept will be parentheses 0, 2. For the second equation, we need to solve for y. We get rid of the minus x first by adding it to both sides of the equation. Simplifying this equation, we get y equals x minus 2. Now that this equation is in slope-intercept form, we could see that the slope is positive 1, and the y-intercept is 0, negative 2. Because the slope of these lines are equal, and the y-intercepts are different, this indicates that these two lines are parallel. Moving on to part B, we have the equation negative x plus 3y equals 2, and we have a second equation, 2x plus 6y equals 5. We need to put both of these equations in slope-intercept form. Starting with the first equation, we need to get rid of minus x by adding x to both sides of the equation. Simplifying the equation, the result is 3y equals x plus 2. Next, we need to get rid of the 3 in front of the y. We do this by dividing both sides by 3. We get 3y divided by 3 equals x divided by 3 plus 2 divided by 3. Simplifying the left-hand side, we have 3y divided by 3 is just y. On the right-hand side, x divided by 3 can be written as 1/3 x, and we bring down the 2/3. So the result is y equals 1/3 x plus 2/3. The slope for this line is 1/3, and the y-intercept is 0, 2/3. Next, we need to put the second equation in slope-intercept form. We get rid of the 2x by subtracting 2x from both sides of the equation. Simplifying this equation, we get 6y equals negative 2x plus 5. Next, we get rid of the 6 in front of the y. We just need to divide both sides of the equation by 6. We get 6y divided by 6 equals negative 2x divided by 6 plus 5 divided by 6. Simplifying the left-hand side, 6y divided by 6 is y. Simplifying the right-hand side, we have negative 2x divided by 6 is negative 1/3 x, and then we bring down the 5 over 6. The result is y equals negative 1/3 x plus 5 over 6. We can now see that the slope is negative 1/3, and the y-intercept is 0, 5 over 6. Because the slopes are not equal, we know that these two lines are not parallel. Next, we need to check whether or not they're perpendicular. We just take the two slopes, multiply them together, and see if we get negative 1. So we have negative 1/3 times 1/3 is equal to negative 1/9. You can see here this is not equal to negative 1, so this indicates that these two lines are not perpendicular. Since they're not parallel or perpendicular, we just state that these two lines are neither. Next, we have a practice problem for you to try. Determine if each pair of equations are parallel, perpendicular, or neither. For part A, we have the equation 3x plus 7y equals 21. The second equation is 6x plus 14y equals 7. For part B, we have the equation 2x minus 3y equals 12. The second equation is 6x plus 4y equals 16. So go ahead and pause the video, try out these problems, and then check back with the video to see how you did. Alright, so let's get started with part A. We need to put both of these equations in slope-intercept form. Starting with the first equation, I need to get rid of the 3x. So I'm going to subtract 3x from both sides of the equation. After subtracting 3x from both sides, we get 7y equals negative 3x plus 21. From here, we get rid of the 7 in front of the y by dividing both sides by 7. So we get 7y divided by 7 equals negative 3x divided by 7 plus 21 divided by 7. From here, we go ahead and simplify the left-hand side. 7y divided by 7 is y. And on the right-hand side, negative 3x divided by 7 can be rewritten as negative 3 over 7x. Next, we have 21 divided by 7, which is 3. So the result is y equals negative 3 over 7x plus 3. The slope is negative 3 over 7, and the y-intercept is 0, 3. Next, we rewrite the second equation in slope-intercept form. First, we get rid of the 6x by subtracting 6x from both sides. After doing the subtraction, we get 14y equals negative 6x plus 7. Next, we need to get rid of the 14 in front of the y. We just divide both sides by 14. We get 14y divided by 14 equals negative 6x divided by 14 plus 7 divided by 14. Simplifying the left-hand side, 14y divided by 14 is y. On the right-hand side, we can rewrite negative 6x divided by 14 as negative 3 over 7x. And 7 divided by 14 is 1/2. So the result is y equals negative 3 over 7x plus 1/2. The slope is negative 3 over 7, and the y-intercept is 0, 1/2. Because we could see that the slopes are equal and the y-intercepts are different, this indicates that the lines are parallel. Moving on to part B, we need to put the first equation in slope-intercept form. First, we get rid of the 2x by subtracting 2x from both sides. After subtracting 2x, we get negative 3y equals negative 2x plus 12. From here, we need to get rid of the negative 3 in front of the y by dividing both sides by negative 3. Doing the division, we get negative 3y divided by negative 3 equals negative 2x divided by negative 3 plus 12 divided by negative 3. Simplifying the left-hand side, negative 3y divided by negative 3 is y. Simplifying the right-hand side, negative 2x divided by negative 3 is positive 2 over 3x. And then 12 divided by negative 3 is negative 4. So the result is y equals 2/3 x minus 4. The slope for this equation is 2/3, and the y-intercept is 0, negative 4. Next, we need to put the second equation in slope-intercept form. First, we get rid of the 6x by subtracting 6x from both sides. After doing the subtraction, we get 4y equals negative 6x plus 16. From here, we need to get rid of the 4 in front of the y. We just divide both sides by 4. Doing the division, we get 4y divided by 4 equals negative 6x divided by 4 plus 16 divided by 4. From here, we can simplify the left-hand side. 4y divided by 4 is y. On the right-hand side, negative 6x divided by 4 is negative 3 over 2x. 16 divided by 4 is positive 4. The result is y equals negative 3 over 2x plus 4. The slope for this equation is negative 3 over 2. The y-intercept is 0, 4. From here, you could see that the slopes are not equal, so this means that these lines are not parallel. Now we need to check if they're perpendicular. So we need to multiply the two slopes together. Here I have 2 over 3 times negative 3 over 2. This equals negative 6 over 6, which simplifies to negative 1. Because the product of the slopes is negative 1, this indicates that the lines are perpendicular. Alright, so this is the end of our video. I'm Professor Diwa, thank you for watching, and I'll see you in the next one.